Hello. I've moved that because I saw what's happening. Yeah, so let's admit it. Kotlin has got some great features that will make our code clear and concise. But if we don't know how to use those features or use them in the wrong context, then can actually trip us up. So today we're going to look at some Kotlin features that are not as popular as, like now safety kind of features. And we're going to do some live programming. I'm using Kotlin notebooks. That's the first time I'm using it, so demo gods will be with me. And we're going to code, we're going to see the side effects, and then we're also going to look at some benefits of those features if you use them in the right way. So let me just scroll. So I'm Elena van Engelen. I'm a senior software engineer specializing in Kotlin and cloud-native solutions. I'm working currently as a lead engineer at AZL. It's a life and pensions of the NN Group, so also finance like ING, very relevant. Also co-author of Kotlin Crash Course, you've heard just now, and a blogger on Kotlin and cloud topics. I'm not going to talk about cloud today, so only Kotlin. And talking about books, if somebody asks you to write a book, say no immediately. Just don't do it. It's like giving birth to a child, only it takes a lot longer than 9 months. Don't do it. Anyway, going forward, we will start with some simpler features. I thought you can read the code. Yeah? Okay, so the first is safe collection access. This is a lesser known feature because normally you don't access items by their index, but sometimes you integrate with generic APIs or APIs, third-party APIs, or some SDKs which have got some lists, and you know that in some index there's an item that you want to access. So let's consider this scenario. I have a list of addresses, and I have a shipping address. It's always there because you have to ship your order somewhere, right? And I also have a billing address, but billing address is optional. It's only there if my billing address is different from shipping. So you can see already my code, right? So if I run this, right, it's going to crash, right? It's going to crash. Yeah, because of course I only have a shipping address there, and I'm trying to access the billing address. So let's just copy this. We're going to put it in a new cell, and now I'm going to first do the traditional way. So what I can do, like with the traditional way of checking, of course, I'm going to check the size of the list. So I can do it if addresses. Ooh, I erased my. Right, so size more than 1. Ooh, 1, right? Then I can access the first element. Else no. Yeah. So that's the traditional way of doing it. So if I do a print of it, billing address, well, actually, let's give it like some more text. Yeah, billing address is billing address. Thank you, AI. I'm not doing anything with AI, just thanking it. Okay, so billing address is null because, we only had a shipping address. So, if we want to do like an alternative, so what we can do is we can say, okay, if you didn't provide us a billing address, then actually it's the same as shipping address. So, I can do with default. So we do it with default, and then I'll give it the shipping address instead. And let's print that. Thank you, AI again. Right, so let's run that. So, okay, so if we don't have a billing address, I can default to a shipping address. But we can do it differently with a nice function of Kotlin. So instead of doing these if statements, I can just do addresses. Not with a 1, addresses, then get to no and give it an index 1. So then I don't have to do an if statement. In this case, I want to fall back to a default, so I can do a very similar thing. So addresses, get or else, give it an index, and then give it an alternative, which is the shipping address. So now, okay, that's fine. If I run this, then I get the same result. It's a lot neater, right? So can you think of a side effect of get to null or get to else? When should I not use this? Can somebody tell me? Sorry? Yeah, so you shouldn't use it when you have a mandatory element. So let's say you can see here I'm accessing this shipping address. And I'm accessing it directly because I say, well, it's always there. Well, let's say I don't know if it's there. And then I'm going to do addresses, yeah, and then I'm going to do get or null and 0. And in this case, if I run this, I will remove this address, so it's going to be like empty list because we haven't got any addresses. So to get this side effect, of course, we need to make sure there's no addresses. So I got like an empty list. It wasn't supplied. No, I don't want that. Okay, run, and then everything's null. So I don't know where to send my order, or I'm sending a letter nowhere. Or it could be that I'm getting some data for my letter, like details of like the name of the customer which I want to send to, and I can't fill it in. Have you ever received this email? Dear, no name or some kind of like variable, and then they send out these emails if they don't have the right name. Sometimes it like kicks up. So you don't want that, and for that you want to actually make sure you do the traditional way of validating. So yeah, so in this case, get to null, get to else works really well for optional things. But if you have a mandatory, which is basically this address, then you actually want to say, yeah, do some validation like this. And then you say, if it's empty, then you do validation of this. Okay. Print ln something else than this. Shipping address is mandatory. And then basically you say else, you do your good thing, basically. So if I run this now, it will say, sorry, it's mandatory. And then when I put the address in there again, then it will work again. So so only for optionals you should use that, and not for mandatory elements. You can of course do checks on null here and assert on nulls, but I think with arrays you can also check for size. Next, safecast operator. So safecast operator can be very useful. I have some war story about it in our own code base, so I'll tell it in a minute. So safecast operator, when you have a generic type, and you get that with generic APIs, like I use a lot of SDKs to connect to third-party services. They're quite generic. You can have generic API connecting to APIs, other APIs. And then it will return you a generic type of some sort. And this type doesn't fit into your implementation. So let's have a look at this one. So this doesn't compile because my input is any. And I know it's a string, right? So I can just say the normal cast, right, string. But if it's not a string, then it will fail. So what I can do, let's just go into my cell. So what I can do is I can do a safecast. So if I do a safecast, it will cast it into a string. And if it can't, it will give me a null. Right. So if I am a string, then this will work. And if it's not a string, it won't work. So what you can also do, of course, is give it a default. Because it's a null, you can give it like a default, default string. I have a space here, it doesn't matter really. Yeah, so then it only will give me a default string if this is done the wrong argument. Right, okay, so can someone tell me what's the side effect that could happen if I do this? Right, so the side effect that we experienced in our code was that you get a null, right? You get a null. And what we had was we have this third-party tool called Service Bus. And you can send a payload, and you can send metadata with that payload. And the metadata is very generic key-value pair. You can see here, like a key and a value, any value. And it supports all sorts of basic types like float and date and string. If you send a message with the metadata and you don't specify the type, Service Bus can say, oh, I know this is going to be a float. So it's going to assume the type and provide it. So as a consumer, when you read the message and the metadata, it will arrive with that type. We have loads of teams, and then the teams have agreed we will send the version number of the event, because if you send a different version of your event, you want to be compatible with all sorts of different versions, potentially, of the event. And we agreed it's going to be a string. But one team, they didn't specify a type. They sent an event, and we said, guys, you're not sending us a version. So like I run this, and version's null. I said, you're not sending a version. Oh, yes, we are. No, you're not. Oh, yes, we are. Basically, I lost the value because it's a null. So then I asked myself, why should we cast it to a string? We could just do toString. So in some situations, like specifically, like you cast to a string, then you need to ask yourself, is the type really important to you? Or can you just do a toString to get the value? The other thing you could say is, I want to first log it, the value, before I do this cast, because you will lose it immediately with this null. So, for example, they sent us another ID, like it was a string ID 021, and if you send it without specifying a type, it becomes an integer, so it becomes 21. And of course, that doesn't match with it. So that kind of things can happen, and if you at least log what's arriving, then it's helpful. So this is the gotcha. But it can be very helpful. Well, let's first look at the things when you shouldn't use it. So when you shouldn't use it, if you have this class hierarchy, sealed class of sealed interface user, data class admin, guest, and some other user. So and if I want to handle all of them, I shouldn't use safecast, because I want to be just doing a when, right? So I want to do when admin print something. Not this, thank you. So I want to print the admin. Let's print the admin's username, I think. Thank you. And then if it's a guest, then we'll print that. So guest is me, yes, guest is me. Okay, so in this case, you don't want to use the safecast operator. But there's also very good place to use it. So let's consider another example. And this example is basically, I have a pension account. And a pension account can be active, it can be suspended or closed. And in this case, I only want to do something with an active account. Suspend and close, not important. So in this case, I can use safecast operator, and it can be quite helpful. So if I get an account, I can just say, and I don't know which account it is, but I'm only interested in the active one. So then I do account active. If it's active, and because it will give me a null if it's not an active, I can just do the null check, right? So I can do a let, and then only when account is not null, I can do some, let's just print something, account number like this. So let me just close this bracket so the thing compiles. So here I'm sending an active account, and it will say active 123 if it's active. And if I now change it to, let's say, suspended, and then get rid of the amount because it doesn't have anything, and then give it, yeah. it doesn't print anything because I only do something with an active account. Let's say I just calculate all the balance of all my active accounts. I don't want to do anything with inactive. So this is quite useful, specifically with when you integrate with a complex API, which has a lot of object hierarchy and comes back with all the different things. It could be useful. Has anyone used the safecast operator? Okay, yeah. Built-in assertions. So I already start with saying only use this when you want to basically validate a bug. So there's a bug in the code and you want to throw an exception. Don't use it for validating user input or API validations, request validations where you want to return error 400 or that kind of validations. You shouldn't use that. So let's consider this example. Add item to cart. So I have this item, but if the price is less than 0, then basically the customer not only gets the item but also the cash with it, and that's not what I want. I don't want people walking away with iPhone and 500 euros. So if I run this, it will say, sorry, we reached this place where it's not correct. The application should not allow an item with a negative price. So what I can do instead of this traditional one, I can use the built-in function require. And it's actually positive because instead of like doing a negative check, I can do a positive check saying require that the price is more or equal to 0. It could be free, of course, so that's fine. It just needs not to be negative because we don't want to pay customers to buy our products. Right? So if I do this and run, then it's exactly the same, but it's a lot neater, I think, than this. Let's just clean up our output. So yeah, and it's also more readable. I require that the price is more than 0. So next one is not now, very similar. So I have a shipping address in the shopping cart, and it needs to be, by the time that I'm checking out, it needs to be filled in. If it's not filled in, then some other part of my program didn't work to make sure that the customer entered it. So this is not customer input validation, this is validation of my program flow. So again, let's do this quickly because I know that you guys already know what I'm going to do. So I'm just going to say check not now. Oh, yeah. Sorry. Require. You're right. Require not now. And then what I'm going to do is I'm going to notice that I'm using the lazy message. So what this does is actually it validates this message only when the shipping address is null. So only when the require, basically the check is false, only then it will evaluate this string to actually throw this exception. So let's run that. So it says, sorry, the shipping address is null. This is not a valid state, valid argument in your program. So let's go straight to the internal state. So very similar, you can validate the state of your program, so illegal state exception instead of illegal argument exception. So I go through it also quickly because I think you guys know what I'm going to do here. So if the order hasn't been paid, we shouldn't ship it. So we reached an illegal state in our program that it didn't ensure that the order is paid. So again, we're being positive, not order paid and throw exception, but check order is paid, and then the lazy message. Right? If I run that, it will say, sorry, order should have been paid. If it was paid, then I wouldn't get this problem. So, again, this is the one we use quite a lot, I have to say. The next one, validate not null. So this is basically check not null. If you have a situation where you expect something not to be null, you could be throwing an illegal state exception when it is. So for example, in this case, I'm trying to get the properties file, config properties, I have it. If I do like this, then it will work, and it will print me what's inside the properties file. So actually, if I go here, there's this properties file, config properties. So it's there. Now, if I scramble and put rubbish in, then it will throw illegal state exception. So instead of doing all of that, again, I'm going to go quickly because you know what I'm going to do now. So I'm going to do check no null. All right. Get rid of the manual throwing exception and just give it a lazy message. And it works very similar to the previous examples. I forgot the bracket. So run this, and then you get the illegal state exception. When the thing is not there, if I'm correcting it and my file is there, then there's no programming error and it's going well, printing out the result. Okay, has anybody used any of those built-in functions? Yeah. Okay, so next one is the final built-in function, and that's called error. This is a nice one because we did have some issue with it. So let's just have a look at this one. I have this process payment. I process credit card, PayPal, and nothing else. And I definitely don't want cash because, you know, money laundering, you know, you don't want that. Right, so I'm sending in cash. If I run that, it will fall over. So instead of doing this, we can say error. All right, so we're going to do error here. But, oh, wait, I'm not doing a lazy message here. Can somebody say to me what's going to happen if I use lazy message here? What will it print? Anybody? Well, so what will happen here, it will give me this. And this is basically a toString over lambda, because error doesn't support lazy message. And you only discover it when it, you know, reaches that error state, that you don't have a nice message. That's not nice. But basically, that's because error doesn't support it. And there's a good reason for it. If you reach this part, you don't need lazy. You have to execute that. You already reached the error situation. So there's no if. If you reach that, just, you know. So let's go into it. Like, if I go into it, you can see here. So error doesn't support lazy message, just a message. And you can see check not null does support lazy message. So, okay, so that's the little thing that we had in a few places in the code that we had to fix as well. Okay, so let's go to error handling. That's a really nice subject because in the first session, you guys heard about what's coming, right, in Kotlin, that they will have some rich errors, which is very nice. Now we don't have that. So Kotlin doesn't have checked exceptions, which is, I think, very nice. I come from the Java background, so I know what checked exceptions are. So Kotlin encourages you to always return a result when you have a recoverable error. So in this situation, for example, we have this custom type, a parse result, very simple. So you have success when we want to parse the integer, right? And if it's successful and we parse the integer, we return a success. If it's not successful, we return an error. So like this is an 1, 2, 3 integer, it will be successful. If I give it rubbish, then it will give me an error. So this is what Kotlin encourages us to do, and with rich errors, we will be able to do it even nicer. However, on JVM, we integrate with Java libraries, right? And Java libraries throw checked exceptions. Ooh. And they become unchecked when they come to us, so it's not like we can ignore them. So what it is that once they when you have some checked exceptions, you either have to drill down in all the things that you call and try to see which ones are checked exceptions and trying to catch those and handle and whatever. So let's just have a look at a simple example. So it's a simplified situation. So I'm writing this parse date function, and it's using Java SDK to parse the date. And this actually throws checked exception. If you look at that, this throws a parse exception. This is a checked exception. But it could be that I have like loads of other things going on in my in my implementation of the parse data. I could be doing other things or whatever, which also throw some checked exceptions. So you could have some complicated things going on. This is actually a bit, when we integrate with some SDKs that connect to third-party applications or to the cloud, we do have those situations where you really need to catch those exceptions. So you can't like ignore and let it bubble down to the framework and let the framework handle it, because you need to react to it and make sure that your application works. So what you can do, there's a built-in function called run catching. And that run catching returns a result, and that's what we're going to look at in a minute. So, okay. So what I can do here, right? So I can do run catching, and I can wrap my parsing and get rid of this. And that means that actually I can return a result with a date. And actually the result, if it fails, it gives me an basically failed result. And if it succeeds, I get the date. So the result itself has got loads of extension functions like handle, on error, whatever. So you can see here, so you have some extension functions. Is success, is failure, you can check. You can check it and you can do something with it. So that's what we're going to do. So instead of all of that, we're just going to say, this is now returning a result. You can see here, a result with date. So what we're going to do here, we're going to say on success, and we will print it like we did before. But now, instead of crashing, we can also do, let's just put it on the next line just to make it more readable. On error, on failure, actually. AI is sometimes a bit weird. Right, so no, on failure I said. Okay, thank you. Right. So then a not reason message. Okay, so now I can handle my success or failure. So what it is that I have this API now, like internal API that helps us, a helpful function. But now I'm telling the users of my API, you don't only get a date, but you also can get a failure together with the date. So yeah, so then you have this parse date when it's good, right? But let's just put gibberish in there. And then I get an error, unparsable date, because it will print this part. So I'm handling this error. Can someone tell me what the side effect is of run catching?
Cancellation exception, for instance, probably also violates structure.
Yeah. So run catching, it actually catches throwable. So you have the try. So if you look at the run catching, so you have try, it takes your lambda, it will execute it. If that fails, it will wrap your throwable into result, failure. So that means that you always have to know about that. It's basically the same as doing try catch throwable and then wrapping that and then passing it to the caller to handle. So that's very important part to understand. So throwable means cancellation exception if you are within coroutines, but it also means error, like out-of-memory error, and all sorts of different JVM errors that you probably don't want to be suppressing. So that's very important to know about this run catching. And if you do know it, then you can use it. If you always have it in mind that this is happening. I'll tell you a war story that only actually came across it working badly once. So I'll say it in a minute. So in this case, let's just have a look how it works. So I have this boom function, and this boom function goes into an infinite loop because I will add one to it and just go into an infinite loop. And then I have the sign and crash function, which does only run catching and doesn't do anything with the result. And as you heard from Michael, that they will validate where you don't actually do anything with the return type later on in Kotlin. Right now, that's not happening. So I'm not, maybe I don't know about run catching, how it works, and then you have to do something with the result. I've just done this run catching. And if I run this, it's green, nothing's happening. So if I move this right outside and I run this, basically the notebook, it does handle my result because it just prints it, right? So you can see that my silent crash function ignored Stack Overflow error. And I was working at a really big retailer company, not saying any names because I know some people work there, right? That was in the past, long time ago, right? So, and there was this service that was every 2 days, it was just crashing. It was running out of memory. We saw it in the Grafana or whatever. We saw in the monitoring. It was running out of memory, and there was no errors. We were like, "What's going on?" And eventually, it was quite a long time till we found it because at the time there was mostly Java developers in the team, and our Kotlin developer went on holiday, whatever. And and then in the end, we thought it was this run catching. But it was not obvious because we were looking for this try, catch, throwable, ignore. But there wasn't there because it was this, right? So as long as you know what it's doing, you can use it, right? It is a controversial feature. I know it is. But if you know what you're doing and you make sure that you have your code analyzers check for all the things and you do good code reviews and everybody knows what it's doing, it's fine to use, I think. But, okay, let's just have a look at the advantages of using it. So let's look at this example. So I have this traditional example. It looks very like Java. Don't you agree, like Java people? Right, so I want to read a file. Now, first I'm going to have a buffered reader nullable. And that's because I want to close it in the end, right? And then I'm going to read the file. If I can read the file, I will get the content of it and return it as a string, right? If it fails, I want to do some extra logging. Maybe I want to add some custom things to my logs, which is available in the current context. I want to throw it. I don't want to, do any fallbacks. I could be doing IO exception, file not found exceptions here as well, but okay, whatever. And then finally, I want to close it. And if it fails, I don't want to crash, right? Okay, you can do it this way, but you can also do it in another way. And this config property exists. So let's get rid of this null. I like getting rid of the nullable thing. Right, and then what I want to do here is I want to do run catching. Right. Yeah, AI. Right. And what I want to also do is make sure that my resource is closed. So I can use a built-in function use. Run catching doesn't have anything for finally, but you can use, and that actually closes your resources. I'll explain it in a minute. So I don't need this anymore, and I don't need the catch. So what this is doing, it adds some extra logging, and then rethrows exception, and I don't need the finally because I'm already closing the thing. So all I need to do here is add my extra logging, basically, what I was doing. So on failure, so let's get rid of all of that. And maybe, I don't know, formatting. Maybe you can use a different formatting to make it look nicer. But maybe I can do it like this. Maybe it looks nicer like this. Yeah. Okay, so what I've done is I've moved from this to this. And this is a lot nicer. Let's just scramble. So now this file exists, so I'm getting hello. I scramble the file, and then I get this extra log line, which I actually wanted to do, and then my crash, because I'm actually throwing exception further. So basically, I'm closing resource here, and I'm doing it in a neat Kotlin-like way, instead of doing all that with a nullable property there. So if I look at the use, because I've recently got a question, how does this close the resource? So let's just go inside there. So what it does, the use, is it takes your lambda, it calls it, and if when it's finished, it will just do the finally for you. And it will try and close it, and if the close fails, it does the standard thing, what you normally do with close. So basically, that's the use. Make sure that if you use that, you use it directly on the resource. No if statements before, because otherwise it won't close all the time. So always use it on the resource, and it will be fine. So this is the result. So if you're not afraid of your catch throwable, which is inside the and catching, you can do a very nice code like this. And of course, you can do some extension functions on that to make sure that you rethrow. If you want to rethrow your cancellation exception or do something else, you can always add some extension functions to do all sorts of extra things that you want to do. If you want to handle specific exceptions, you can. This is done the nicer way of doing it, I think. Let's go to another example. That's my final example of this run catching. And look at this quite complex example. So let's just explain what it's doing. So what I want to do, I want to read the file. And if everything goes well with my reading file, this file contains JSON. I want to parse this JSON. If this parsing, maybe I do some schema validation. I'm not doing schema validation here, but I could be doing schema validation. So I'm parsing this JSON. If that goes well, I want to process it. So I have this input JSON, which has some data in it, data which is an int, and then I've got the result, the process result. It's a return of my function, and this basically will do something with it. At the moment, it's just doing 42 divided by the data. So that I know it can throw an exception. So yeah. So I've got these three, let's say, imaginary, really complex operations that can be throwing exceptions, and I want to do some fallbacks. So let's say with the file, if it's not there, I want to fall back to a default, and when parse JSON doesn't work, I want to fall back to a default as well. But finally, if I process data and if that fails, I don't want to fall back. That's just like an example to show how the extension functions on the result can make it look nice. So let's just run this verbose code. So now it's giving me a 1, and that's because if I go to my file, input JSON, it has 42. So I'm dividing 42 by 42, and of course that will give me a 1. So let's just rewrite this and use run catching result and extension functions of the result. The result has quite a few extension functions. Result is actually quite old, from Kotlin 1.3, I believe. Yeah, and run catching as well. Okay, so let's just redo this. So what we can do is do run catching. So we're reading the file. And here we want to do a fallback, right? So we want to recover. You can also recover catching if your recovery can fail, but I'm just going to do recover. Right, so I'm recovering. But what I want to do is, when I've read the file and it's successful and I've got this file contents, I want to do something further with it. I want to actually, I want to transform into JSON, right? So I can do map catching, and map catching will actually also catch any problems if they will occur with my parse JSON function, right? So I can do this. It's actually quite short, so I can just put it on one line. Yeah, it's not very nicely formatted. Okay, so map catching. And then basically in this case, I want to fall back on this default value. So then again, I can do a recover. And So I'm recovering if this fails. And then basically at the end, after I've recovered, I'm doing the last thing, which is the process data. So then I want to do map catching, and then I'm going to process my data. That's the last step. And the last step I'm not going to recover from, so I'll just do, here it's logging extra things. On failure, let's just copy this. And then, and then I just want to get to throw the last part, because I'm actually not doing anything with that. Yeah, so basically you can kind of make it more readable, because my formatting is not really great at the moment. But basically you say, I run catching, and then if this fails, I want to recover. Let me just try and format this. No. So if I want to recover, I can do some recovery on it. I don't know why my editor doesn't want to format. And if I recover it, then I can pass the JSON. Or if this actually went well, I can also pass the JSON. If the JSON parsing failed, I will do the default here, and then I will fail at the end if it doesn't work. So at the moment, I did the wrong. Wait, here is it, and it's. You can also give it a name as well there, like E, like that, if you want to. But I don't. So, okay, run. 1. So that's because my data is. So let's just have a look at the errors that's going to be generated if I do some bad stuff. So let's just fail this, because we're going to give it a wrong file. So then it will fall back to the 42, and therefore it will print me, oh, this is failed, but because we're falling back to the 42, it will be dividing by 42. But let's fail here as well. So what we're going to do is we're going to give it a 0. Wait, no, not here. Here I'm going to give it a rubbish, and it will not be able to pass me the JSON. So then it failed twice, because it can't pass the JSON, and it falls back to this JSON with 42. And if I then give it a 0, it will fail again, because that will be dividing by 0, and then I have the. So you can make it like nice. Like if I don't need to do any logging, maybe I can format it better so you can see that it's normally more readable in the editor. I'm currently in the notebooks, so it's kind of not formatting the way I want. But yeah. So if I don't want to do any logging, then right. So you can kind of like make it look nice with this recover, because you can say run catching, recover if it fails, map catching when it's successful, recover again, map catching on failure. So there's loads of different methods from the result that you can use. But this is really when you interact with libraries that throw exceptions and you want to handle those. But normally Kotlin doesn't want to handle or try catch anything. If you're writing your own libraries, you should use rich errors which are coming in Kotlin 2.4. That's it. Do we have any questions? If you need any extra information on these features, I actually have blogs on every one of them, so you can scan this code and you can come to my blog and you can read more about them. Questions?
Hi. Thank you for the information. I just have one question. In get or throw, in the last example that you showed, can we throw any custom exception? Like if I want to say that this is the particular kind of exception that I throw because it sort of is expected in my front end, and that is how I want to handle it. How do I do that?
Yeah, you can. Normally, you can just do anything you want to do, like you do it in Java. But normally, you shouldn't throw any custom exceptions, because if you want people to catch them and recover, Kotlin actually advises you to have it in your return. So like with these rich errors, you will have the successful return pipe error return. So basically, if you are expecting a failure and you're writing the code, don't throw exceptions. So that's basically the bottom line of the Kotlin one. Yes, any more questions?
I think if there are no other questions, then we can end here, unless someone really raises their hand right now, because this way we are perfectly on time and we have 45 minutes for the other presentation. Nobody? Then applause. Thank you so much.